Hi guys, welcome back. This is the last of the Carbonyls videos and we're going to be covering the last couple of pages, which is about Grignard's reagents. Okay, so you'll need your notes and we're starting on page 21. Okay, so when this is finished, you should have finished all the notes and you should be uploading your answer copy. I just want the answers at the back of the pack. I don't need the whole pack. So you could scan and copy those, and I need those up by 5 o'clock on Friday, please. Okay. So you should be on page 21 of your notes, and we're looking at these Grignard's reagents. Now, you've all got access to the chemistry textbook. You either take one out from the library, or if you haven't, don't worry, you can get an online copy. So I strongly suggest you kind of read over these pages, okay, preferably before we start. So if you want to pause the video at this point and go and find a textbook and just read those 2 pages, that would be a good place to start. Okay, so I'll give you a chance to do that. Okay, so hopefully you've had a chance to read that so you'll know where we are in this. Okay, so Grignard's reagent is basically what we call an organic metallic compound. So it's unusual in that it has this metal in it, magnesium. Okay, and that changes the chemistry of this group. Normally, the carbon here is pretty much always delta positive, because all the things it's connected to tend to be more electronegative than it, oxygen, nitrogen, and so on. But in this case, it's actually got a magnesium attached to it. Here it is. Okay, and that magnesium is making that carbon actually delta negative, because for once, the carbon is the more electronegative species. So this carbon becomes delta negative. Okay, so because it's delta negative, it can donate a pair of electrons. So that's why it's nucleophile. It's a nucleophile because it can donate a pair of electrons, because the carbon here is delta negative. Now, therefore, this is going to act also as a reducing agent. Okay, now remember, reducing agent, if you go back to your little oil rig, I'll write it on the side, O-I-L-R-I-G. Now, a reducing agent is reducing something else, it itself gets oxidized. Well, oxidation is loss of electrons. So this carbon here is donating those electrons, it's being lost, these electrons are being lost from the carbon, and therefore it's acting as a reducing agent and as a nucleophile. Okay? Now, they're very, very unstable. Okay? And we need to make them very, very carefully. So what we're going to do is we're going to take a halogenylalkane, usually an iodoalkane, but I could use a bromoalkane instead. And I'm going to react it with magnesium, and I'm going to react it in a substance called dry ether. Now, dry ether just means, dry simply means it's just got no water in it, and ether is an organic solvent, because I can't get this wet, because this thing here, this Grignard's reagent, reacts very, very violently with water. Okay, so we have to be a little bit careful with it. In fact, that's one of the reactions we need to know, because if it gets wet, it will react and you will basically get this alkane. So it is one way of changing a halogenylalkane into an alkane. Okay. Now, we haven't studied halogenylalkanes in any detail yet, but you just need to remember they are a carbon chain to which I've attached a halogen, a chlorine, bromine, or iodine. You don't need to know too much about their reactivity before we do this. Okay, so we're just one way of turning a halogenylalkane into an alkane. So we can add that to our spider diagram later. Okay, but the reactions we're really interested in, because this is the carbonyl pack, are the carbonyl compounds, and they react with Grignard's reagents to form alcohols. Okay, so the first step is to react our Grignard's reagent, here it is, got a carbon chain here, with our aldehyde or a ketone, and initially we make this substance here. Okay, but that's not the final product. The final product is the alcohol. So what will happen is we will add some water or some dilute acid, and this group will get lost off the end, and you will get a hydrogen here. So you're making the alcohol functional group. Okay, so let's have a look at that in a bit more detail. So if you turn over the page, to page 21, you can see at the top of that page there, you then do the second step, which is hydrolysis in the presence of a dilute acid. So water actually technically counts as a very dilute acid, but you will sometimes quite often see it done with HCl in an aqueous solution. So dilute hydrochloric acid will work just as well. Okay, so either water or a dilute acid works fine for this. And basically, as I said, you lose that MgX, that magnesium with my halogen, and you make MgXOH. So basically you put all the inorganic parts together and all the organic parts together here. Okay, and there are some examples down the page. But actually I'm going to turn over to page 23. And I'm going to basically do the reactions again, but on this page, because I just want to point out how this actually works, and I want to do a bit more of a mechanism for this reaction. So I'm going to start with my ethyl magnesium iodide. So ethyl means it's got 2 carbons in it. On the page a bit, there we go. Ethyl means I've got 2 carbons. So I've got my CH3CH2, and then I've boiled it up with some magnesium in dry ether to make my Grignard's reagent. Now to that, I'm going to add my very simple methanol. Okay, so that's what I'm going to add to it. And then, obviously, later on, I'm going to add some water or some dilute acid to get it to react. Now, what we have to understand is that this carbon here, remember, this is the carbon, which is my delta negative. Now, this carbon here is, as most carbons are in organic products, delta positive, because it's attached to more electronegative oxygen. So the electrons are going to come from this carbon here, and they're going to attack this carbon here. So it's a carbon attacking another carbon. Again, quite unusual, because this carbon here, as we said before, is unusually delta negative. Okay, so this carbon is going to join onto this carbon, and we're going to turn this group here into an alcohol functional group. So I'm going to get a C and another C, and lastly I'm going to get COH on the end. So I've made a primary alcohol, and I can make any primary alcohol I like as long as I start with methanol and some kind of halogenoalkane. So I can make this chain longer or shorter, and it will make this primary alcohol chain longer or shorter. So this works with any Grignard's reagent. As long as I've got methanol, I will make a primary alcohol. So let's look at the next one. We're going to start with the same group. Just going to draw this one out a little bit more so you can kind of see it in a little bit more detail. There we go, like that. Okay, and remember that this group here, delta negative. Okay, and this time I am going to add another aldehyde, just not methanol. So I'm going to do another one. I'm going to choose that one. I'm going to choose ethanol. Okay, and again, my electrons are going to come from the carbon here to this carbon here. So this is a carbon-carbon attack, but it's attacked by a delta negative carbon onto a delta positive carbon. Okay, now you have to be thinking very carefully about where this carbon group is going. Okay, so I'm going to draw my product again. I'm adding water in my second step, or as I said, dilute acid works just as well. So I've got the CH3 group, that's that one, and I've got my CHH. Now I'm going to do my aldehyde functional group, or what was my aldehyde functional group, in a different colour. So I've got the C there. I've still got that CH3 attached. I've got my H, and I've now got my OH. Now you should see now, there's my longest chain, and that OH group is on a carbon with 2 R groups on it. So this time I've made a secondary alcohol. Okay, I've actually made 1, 2, 3, 4. That's on the second carbon, so it's butan 2-ol. So I've made butan 2-ol. Okay, right, one last one, and then I'm going to get you to pause the video and have a go at some on the previous page. So I've got my, again, I'm going to start with the same idea, CH3, C, I, M, G, I. So I can make any primary, secondary alcohol in this method. This time, I'm going to start with a ketone. And again, I'm going to add a bit of water in the second step. Again, because it helps me, I'm going to put the delta negative there, delta positive there. So this carbon, this delta negative carbon, is attacking this delta positive carbon. So it's a carbon-carbon attack. And again, I'm going to draw this bit first. So I've got my CH3 group. I've got my C. And again, I'm going to do my ketone, this time functional group, in a different colour so I can show that it's different. So that carbon, which is my delta negative carbon, is joined onto this carbon here. And this has CH3 group there, and a CH3 group there, and my OH. So basically that CH3 group goes there, and that CH3 group goes there. So you should see here, I've now got a tertiary alcohol. Because this carbon with the OH group on it has 1, 2, 3 R groups. So this is my longest chain, well this is my longest chain, and I have a methyl group and the OH group on the second carbon. So it's 2 methyl, and I've got 1, 2, 3, 4, so it's 2 methyl, butan, and this is on the second carbon, 2-ol. So I've made a tertiary alcohol. Okay, so what I'd like you to do now is pause the video and have a go at the ones on the previous page. So that finishes off the Carbonyls pack. I hope you've enjoyed these YouTube videos. If there's anything you'd like me to go over, if you give me an email message, or you can contact me via Teams to let me know if there's anything you want me to go back over in a little bit more detail. But what I expect from you guys is that you will have completed all the notes, and that you will do the rest of the notes, and you will upload those onto our Got Me Online site, and that has to be done before 5 o'clock on Friday. So I'm expecting you to do pages 24 to the end, so that's the dry lab practice and the questions at the end, and they must be uploaded by 5 o'clock on Friday. Okay, all the best, and I hope to see you soon. And we're also doing some this week on entropy. So if you've got the entropy pack, you can find videos about that as well. Anyway, I'll sign off now. So take care, stay safe, stay isolated, keep well.